All right, let's take a look at this. This is the first lesson in something we're going to be doing really, I think, the rest of the chapter. But this is kind of laying the groundwork for it. We're going to get a lot more specific as time goes on, but we're going to talk about congruent figures. We've already talked about the word congruent, right? So we talked about congruent line segments, right? Congruent angles. And what does that mean to be congruent, basically? What does that mean? It means they're equal to each other, okay? But when you talk about figures, we don't really say figures are equal to each other, so we will definitely... So if I had two line segments, watch. If I had this line segment right here, and then I had the same exact line segments right here. Oops. Let's do this. There. Oh. Where's my... Oh, I got to click on it. There we go. Oh, goodness. Come on. It's not supposed to be that hard. Okay. Now look. These two line segments I copied and pasted. All I did was rotate that one. Okay. So if I copied and pasted, so let's say that line segment is 5 units, whatever it is, inches, centimeters, millimeters, whatever, right? And I said that this was AB, and I said this was XY right there. What could I say about those line segments? I could say that what? AB, or the length of AB, right? If I just put an AB and not a line over top of it, okay, that means that the length of AB is what? Equal to what? The length of XY, okay? Or, it's supposed to be a Y. Boom, there we go. Or I could write it like this. I could say line segment AB is congruent to line segment XY. Some geometry teachers are really, really picky on this. This right here means that the lengths of the line segments are exactly the same, okay? This right here basically means if I took this line segment, picked it up, and rotated it, it would fit exactly on top of this one right here. Everybody follow me on that? So let's say I didn't know that that was true, all right, but I knew this. Then I really wouldn't say, I mean, technically, I guess you could say the length of AB is equal to the length of XY, but a lot of geometry teachers would do this, okay? They would put line segment AB is congruent to line segment XY. Everybody with me on that? I'm not as picky about that. I'm perfectly fine if you just say that AB equals XY, right? But when we talk about congruent figures, we're not going to say that the figures are equal to each other. We will always say that the figures are what? Congruent to each other. So this is the symbol that we're going to be using when we talk about congruent figures. We good? So what does that mean to be a congruent figure? Well, I'm glad you asked. So let's start off with a circle. We're not really going to talk about circles hardly at all in this. If this might be the only time we talk about circles in this chapter. We actually do. I've said this before. We actually have a whole chapter that we just deal with circles, and that's the only thing we deal with. All right. So let's do this. All right. So now what I'm going to do is I'm going to copy and paste it. Copy, paste. I'm not changing the size. I'm not making it bigger. Just going to move it over just so it lines up a little bit better. All right. So if I took this circle right here, picked it up, and put it here, would they line up exactly? Yeah, absolutely. So if I picked this up, moved it over here, boom, they line up perfectly. Well, it's off a little bit because I moved my pen, but you saw it, right? You saw that they lined up exactly. All right, so what could you say about those circles? You could say that they're congruent to each other. All right, let's put some letters and stuff in here. How do we name a circle? We've talked about this briefly, not very much, but how do we name a circle? Whatever the what is. No, not circumference. What's that dot in the middle? Forgot it already? It's not the radius. Haven't heard it yet. It's not the midpoint. It's not the median. It's the center. It's the center of the circle, okay? So M is the center of that circle. P is the center of this circle. I know we haven't talked about circles very much at all, but we have mentioned it, though. We have talked about it. So what do I call this thing right here? What do I name this right here on the left? What do I name it? Circle M. How do I show a circle? You put a circle and a what? A little dot, and then you put M. And this is, what are we going to call this one over here? circle P. Very good. So put the little circle symbol, put P. Now, what can I say about these two? I copied and pasted, correct? All right. Actually, let me say one more thing about this first. Oops. I'm going to put them a little closer together because I'm going to put something in between them. I think you know what I'm going to put in between them, right? Yeah. So let's do this. What did I just draw on both of those circles? The radius, correct. And what do they call this? MN. So that point right there is N, and this is Q right here. Now, right now, if I didn't tell you I copied and pasted them, could you tell that they're congruent circles? No, I couldn't. But if I did this, now watch. If I said that this radius and this radius had the same length, and that's what that little tick mark means, right? It means they have the same length. So if they have the same length radius, now what do you think you can tell me about these circles? They're congruent to each other, okay? They're exactly the same, all right? If they're exactly the same, then they are congruent. Everybody with me? All right. So what can I say about circle M? Circle M is what to circle P? They're congruent. We don't say they're equal to each other. We say they're congruent to each other. So when we do figures, all right, we say that they are congruent, not equal to each other. But a lot of geometry teachers, if they would hear me say this, they'd say, well, you would say line segments are congruent to each other too. Sure, you could say it, but I'm okay with you just saying line segment AB is equal to line segment CD. But when it comes to these figures, these closed figures, I think it's really important to say congruent. Everybody got that? It's not that big of a deal. Just one little extra thing that you have to write, little squiggly on top, and that's it. Okay? Now, what if I had this? Let's make a polygon. Actually, yeah, let's do that. Six-sided. Yep, 6 sides. It's fine. And it doesn't. Right now, this program automatically makes that a regular polygon, but it doesn't matter. Let's just keep it. Let's just keep it a regular polygon. All right. So there's a polygon. Guess what I'm going to do with that polygon to demonstrate what we're going to do? What did I just do to get a second polygon? I used my keyboard. What did I click?
Copy and paste.
Copy and paste. What's copy and paste on the keyboard?
C.
Control C, Control V. Right. Almost every single program that you ever use, if you want to copy and paste, that's how you do it. Control C, Control V. Right. I have a lot of people right-clicking, go to copy. I've seen some people go to File or Edit, whatever one it's under. It might be under Edit, and then go to copy. It's a waste of time. Control C, Control V, copy, paste. All right. Now I'm talking, this is what I talk about in yearbook all the time, doing keyboard shortcuts. All right, so here we go. What if I told you that all of these angles are equal to each other? Okay, I'm sorry, angles. I was getting to my next point. And all these sides are equal to each other. Sides, not angles. Now we are going to do the angles. And I said, okay, so this is a regular polygon. And what do we know about a regular polygon? All the sides are equal and all the what? Angles are equal. All right? So what if I know all this stuff? Did I mark everything? Yeah. So all the sides right here are the same. All the sides right here, they're not just the same to each other, but they're also the same to what? The other polygon. Exactly right. Everybody see that? All right. So when you have a situation, when you have all the sides of one polygon, right? All the sides of one polygon equal, how am I going to say this? All the sides, I'll just write it out. All the sides of one polygon equaling all the sides of another polygon. Oops, what did I put S for? Another polygon. Okay. Now, this is, you have to know two things right now. Later on, we're going to do some stuff. In fact, I think in the next lesson, we're going to do some stuff where you don't have to know all the sides. Okay, but for right now, just know that if you know that all the sides of this polygon are equal to all the sides of this polygon, okay, it doesn't really tell you anything just yet, all right? You got to know a second thing. And I'm just going to write this word in. I'm not going to write every single word. And, okay, and if you know all the what else did I mark equal? All the angles. So if you know all the angles of one polygon are equal to all the angles of what? Another polygon. Then, if you know all that stuff, then what can you say about these two polygons? Then they are what? Congruent to each other. Okay? Let's do one with some triangles because this is too many sides to deal with. All right, so we're going to do one with some triangles here in a sec. Everybody got that? If all the sides of one polygon are equal to all the sides of another polygon, and right there, and all the angles of this polygon are equal to all the angles of this polygon right here, then those polygons are congruent. Now, I probably didn't pick the best picture for this. I should have changed it a little bit. But the fact that all these angles are equal to each other doesn't make any difference, okay? You could have all 6 of these angles being different angles, but if they match up with all the angles of this one over here, then we're okay, all right? So I probably didn't pick the best example, but let's pick a better example with some triangles. So what I'm going to do is I'm going to draw a triangle, right? I'm going to draw this triangle right here. I'm going to draw a triangle, let's say, right there, or a side right there, and then another side right there, okay? I'm going to group it. Control G groups it. So now if I pick one side, it just moves the whole entire thing. Isn't that cool? All right, I'm going to copy and paste it. And I'm going to keep them right there. I could rotate them, make them look a little different, and maybe I will in the next example. All right, but I'll just keep it like this, make it as easy as I possibly can. So we'll call this triangle ABC, and we'll call this DEF. All right, so watch what I'm going to do. I'm going to say, I'm telling you this. You can't just figure this out from the picture, but I'm telling you that this is true, that AB and DE are equal to each other, okay? I tell you that BC and EF are equal to each other, and I also tell you that what? AC and DF are equal to each other. So I've got three sides of one triangle equaling 3 sides of another triangle. Can I say they're congruent just yet? No, because I need to have another thing, don't I? What was the second thing I said earlier? All the angles have to equal each other, okay? So watch this. So angle A, what if I said that angle A is equal to, what do you think it's equal to over here? Angle D. And what do you think angle B is equal to? Angle E. Now, you can't tell that just by looking at the picture, all right? I'm just telling you that this is true, okay? This is all given information. And angle C and F are equal to each other as well. If I told you all that stuff, that all 3 angles of this one are equal to all 3 angles of this one, and all 3, I'm sorry, I said angles again. I meant to say sides. If all the sides of this one are equal to the sides of this one, now I can say angles. Now all the angles of this one are equal to all the angles of this one. What's true about those 2 triangles? They are congruent. Now, here's what I really want you to get on this. We have to name this triangle. So what could I name this triangle right here? Triangle what? There's like several different ways you can name it, right? Let's just call it ABC. Is that all right? Let's make it easy. I could have called it what else? BAC. Could have called it BCA. I could have called it CBA, CAB. There's several ways I could have called that triangle. Could have named that triangle, okay? I just picked ABC. Now, here's the key. Everybody watch. This is super important. Don't lose me on this. It's congruent to this triangle. What's very, very, very important, okay, is that you write this the same way as you wrote this one. So if I went ABC, what's equal to angle A over here? Angle D. So if A goes first here, what has to go first here? The D. Oops, got to put the triangle symbol. That's got to be D. All right? If I then went to B, what am I going to go to over here? I'm going to go to E. And then obviously C and F, right? Everybody see that? It's really important. We say that these sides or these points correspond to each other. You've heard that word before, right? is a little different from the corresponding that you heard earlier with the two parallel lines cut by transversal, but they're the ones that match up. So think of it this way. If I took this, let's group that, and let's group that just so I don't, there we go. Okay. If I took this and I picked it up and I put it right on top of there, then it matches up exactly, doesn't it? See, the A and the D are the same, the B and the E, the C and the F. Everybody see that? So they're the ones that match up exactly. So that's the way we have to write it. Remember I said we could have written triangle ABC a bunch of different ways? Give me another way we could have. CBA? All right. So CBA. So if I call this triangle CBA, what am I going to have to call the other triangle? What is it? FED. Very good. All right. So triangle FED. Let's do one more. I'm not going to beat this to death. Give me another one. Gio, what's another way I could name this triangle? BCA? Okay, let's call it BCA. BCA. And then if I go BCA, what am I going to have to go over here? EFD. Everybody good? I could have done this a few more times, right? With all the different names I could have called that. But they got to match up. If you look at this, every single one, the A and D are in the same spot, aren't they? See, the A is third, the D is third. Right here, A is third and D is third on that one. Okay, the B and the E have to match up, right? There's the B, there's the E. There's the B, there's the E. They match up, all right? It's really important that you get that. Have I run that into the ground yet? I think I have. All right. You could actually just do this. Watch this. Oops, I don't want that. I want this little thing. Oh, come on. There we go. Watch. Are these still... I'm going to ungroup it. Let's do this so they're not upside down. So that's E. What's this one? F. They're not equal. Remember, I made a big deal about saying don't say that they're equal to each other. What are they? Congruent to each other. It's really important that you do that, okay? Even though I rotated it, are they still the same triangles? Are they still congruent triangles, I should say? Yeah, they are congruent triangles, all right? So look at this. How do I know that they match up? It's not quite as easy to see, right? Before, they were exactly in the same spot, right? I could see, oh, this one and this one go together, this one and this one. So what if I rotated it? I could have flipped it too, right? I could have taken it and flipped it and rotated it. Then it gets a little more confusing, right, to see which ones match up. So what's an easy way to see that angle D matches up with angle A? Look at the stuff that I gave you originally. The little lines, the little marks, okay, the little angle symbols. Everybody see that? So angle A has one arc. So you look over here, which one has one arc over there? Angle D does. So A and D got to match up. Everybody see that? It's not quite as easy to see now, but they're the ones that match up. Does that make sense? All right. And then B. How do I know which one B matches up with? Well, it matches up with the one with two arcs, right? B's got two arcs. E has two arcs. C has three arcs. F has two arcs. Everybody got it? So you're going to have some situations where they give you two congruent figures, and you're going to have to figure out which ones match up with each other, but they're going to take one, they're going to flip it, or they're going to twist it, and it might not be so easy just to look at it and see which ones match up. All right? So you got to go by what's given to you. What I just said right there is really important. Okay? So hopefully you understood that. Okay. So we talked about congruent triangles. Here's an example. See, I was about to take that from you because I knew that was going to happen. And I thought, no, he's a baseball player. He could probably hang on to a ball. Here, give it. Here, give it to me. Give it to me.
No, I did not.
Give it to me. Thanks.
That's my telephone.
It's mine now.
You stole it.
That's all right. All right, let's take a look at this. I'm on page 157. I don't know if you have your book open, but if you want to draw that picture, you can. So it looks like we got there. I'm going to copy and paste. And that looks about... Does that look like it lines up with that? Let's see if it does. Oh, yeah, it's pretty good. Oops. All right. And then you've got an angle. Let's do this. Let's start about right there. We'll go like that. And then we'll start here and go like this. And then we got one going up here like this. And we got one going up here like this. Oh man, I missed it a little bit. There we go. Yeah, there we go. All right, that kind of looks better. And then they call this U, V, W, X, and Y. All right, this is kind of like a, I don't know, if you went into a barn or a house or something like that, right? If you took the roof off and you looked at it, you got all these trusses. You ever hear that word? Truss, Truss. These are all the things that like keeps everything together so it doesn't fall over. All right, so these are trusses in a house. The book calls them scissor trusses. All right, it supports a roof or a sloped ceiling. All right, and they tell you this. It's given. It says if. All right, so when they say if this is true, that means it's true. All right, so they give you triangle UVW. Write that down. Triangle UVW is congruent to triangle YXW. YXW. Okay? All right. And they're going to ask you some questions. It says list all the corresponding parts. List all the corresponding parts. So over here, when I say the corresponding parts, what am I talking about? What parts does this triangle have? It's got two parts to it. It's got what? Line segments, right? Sides, right? And it's got what? Angles, right? So those are the parts of these figures. Everybody with me on that? All right. So if I ask you what are the congruent parts of this, what would you say? Angle A is congruent to what? Angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. What's my other congruent parts? Side AB or line segment AB is congruent to what? Okay, yeah, let's go in the same order. So if I'm going A to B, it's going from the one angle to the two angles. So this is going to go from what? D to E. So I'd call that DE. What about line segment BC? What am I going to call BC over here? EF. Good, because I'm going from the 2 to the 3. Do you see that? All right. And then if I call this AC, what would I call this up here? I'm going from the 1 angle to the 3 angles, so I'm going from DF. Everybody got that? So what we're going to do now is we're going to do the same thing here. So let's take a look at the triangles that they said were congruent to each other. UVW. So UVW. So let's do this. Just to make it a little bit easier, let's just kind of color it in. Boom. Or we'll just mark it like that. Okay? So that is congruent to YXW. So let's do the same thing. So Y. Oops, did the wrong thing. Here we go. This will be better. YXW. You get it. It's supposed to meet right here. Made a mess of that. Sorry. But you get the idea. Those are the two triangles. So what are the corresponding parts of these two triangles? First of all, let's do this. Turn this back to white. I really made a mess of that, didn't I? Let's get rid of that. All right. So you see the triangles, okay? So that looks a little bit better. Let me change it back to white. There we go. Okay. So what do you think? Look at this. You can tell by the congruent statement. There's a lot you can tell by the congruent statement. So if you look at it, you don't even have to look at the picture to tell you the truth. Let's just do the angles. So angle U right there. What's angle at angle U without even looking at that picture? Angle Y. Do you see that? But let's use, we can use 2 letters because there's only one angle coming out of this, right? That are named. So we can call it angle U. So angle U is going to equal angle Y. So let's write it down. U and Y are going to be equal to each other. Everybody see that? All right, let's look at the next one. What about V? What's equal to V? X is. That's right. So here's angle V, and here's angle X. So angle V equals angle X. All right, one more. Angle W. What's angle W equal to? Without even looking at the picture. Angle W, okay? Now, we're not going to call it W. Why would I not call this angle W? Because I'm looking at this angle right here, aren't I? How do I know that's angle W? I could be talking about this angle, couldn't I? I could be talking about this angle right here. So what am I going to call it? Instead of just angle W, now W's got to be in the middle. It's the vertex. V, W, what? U. So let's call it that. All right, so let's call it angle V, W, U is congruent. Now watch, look what I did here. If I went V, W, U here, what am I going to do over here? I'm going to go what? X, W, Y. That's good. So X, W, Y. It's like alphabet soup in here, isn't it? There's tons of letters all over the place. So that means what? That this angle right here, okay, that's VWU is equal to what? XWY, this angle right there. Are they all the parts of the triangles, those two triangles? No, what else does it have? It's got angles and it's got sides, right? It's got the lengths of the sides. Again, you don't even have to look at this picture, all right? You can just look at the congruent statement. That's how powerful the congruent statement is, because it tells you everything you need to know in that statement. It tells you what all the angles are equal to, what all the sides are equal to, and so forth, okay? So it's really important that you write them correctly. So let's do the sides over here. So you could just do it like this. Let's do those sides. So UV, you see UV right here? So UV is equal to what? Look at here. Now we're not going to go XY, we've got to go in the right order. So if I go UV, what am I going to do over here? YX. Everybody see that? So look at this. UV is equal to YX. So those two sides are equal. All right? And then, give me, let me just get rid of that. Did I get rid of it? No. There we go. All right, so I did UV. What's another line segment I could do here? Let's do VW. So I could say that VW is equal to what over here? XW, right? XW. Do you see how nice that congruent statement is? I think it's better using this than going up here and trying to figure out which ones. Right now, these aren't too hard because they're just side by side. But what if you had a triangle here and a triangle here, but this triangle, like you flipped it this way, inside out, and you twisted it? Then it might be a little harder to see, especially if some of those sides look really close and you can't tell exactly which one's which. You know what I mean? All right, so like this one, I mean, that's a lot longer than that side. And this one kind of looks like your middle side right here. All right, so on this one, you can kind of look at the picture and tell, but sometimes you can't always do that. Sometimes you want to use your congruent statement, okay? All right, what's the other one we haven't done yet? We did UV, we did VW. What's the other one? Sides. They're sides. We're only using two letters. UW, all right? So the U and the W. I'm not going to put a little arc over it, all right? But UW. So UW. And where's UW up here? It's this long side right here, okay? UW is equal to what? YW. Now, again, the book is pretty picky on this, and some geometry teachers are. I'm fine if you just say they're equal to each other, but what do you think the book is going to show you? They're going to say that they're congruent to each other. So let's do that for right now, okay? All right, so that's what they do in the book, okay? So if you look in the back to an odd problem, they're going to show you line segment, they're going to show you congruence instead of just equals. So that's really important. This thing right here can really, really help you out. Okay, we good? All right, now let's do another one. Now, let's see. Okay, yeah, let's do this. We're going to use that same picture. Yeah. So with all that said, Here's example 2, and it refers to this picture right here. So we're going to keep all that stuff right there. So it says, if they're congruent to each other, it's given, or they say if. If they're congruent to each other, which means they are congruent to each other. They told you that they're congruent to each other. Answer some of these questions. It says, they also tell you something else. They tell you that angle U is 22 degrees. You knew they were going to throw some numbers in here eventually, right? And they also tell you that angle UWV is equal to 30 degrees. And they want you to find angle X. Oops. Find angle X. Okay, that's what you're looking for right there. Let me just push this a little bit off to the side. Let's grab that. Just to give myself some room to write, and so you can still see the picture. Okay, so let's mark this stuff then. That's what I would always do. Okay, I'd draw the picture and then I'd mark it. So angle U is 22 degrees. So this angle right here is 22 degrees. Everybody see that? What else do they tell you? UWV, where is that? UWV, that's this little one right here. So this angle right there is 30 degrees. Question says, find angle X, this angle right there. This is what we're trying to find. You're like, well, how in the world am I supposed to find that when you just gave me angles in another triangle? You didn't give me any angles in this triangle. Well, you kind of did though, didn't you? Because what's true about the two triangles? They're congruent to each other. So that means the corresponding angles are congruent to each other, right? Or equal to each other, right? So that means that angle U is 22 degrees. What's 22 degrees over here? Angle Y. Angle Y is 22 degrees. Because remember we wrote them down earlier? See, there's the U, there's the Y. They're in the same spot. So the U and the Y are equal to each other. So that's 22 degrees. And then, what they say, UWV. UWV is 30 degrees. So what's this angle right here going to be? That's also going to be 30 degrees. It's a little ugly, but you get the idea. So how in the world do I find this angle right here? Yeah, now you do what we did before, right? You know that all three angles of a triangle add up to 180. So you add those up. What's that? 52. And what do you do with that? Take it away from 180, and that's 128. Okay, and so that's that angle right there, 128 degrees. Yeah. Yeah. I want to see it. I want to see this. It only takes you 2 seconds, 3 seconds maybe, if you're a slow writer. Okay, it doesn't take you long. Show me. Okay. Again, this is what I want you to avoid. All right, so say your homework is 1 through 5, okay? And this is what I want you to avoid. I don't want to see 7, 40 degrees, 10, 20 degrees, 13, okay? This is what I don't want to see, all right? I want to see how you got 7, how you got 40, how you got 128, okay? I don't want to see this when you turn stuff in and you can show some work. Now, there are some times where you can't show work. It just might say, given that the triangles are congruent to each other, tell me what angle U is equal to. Well, you would just say angle U is equal to angle Y. There's no work to show for that, right? But if there's work to show, if there's math to show, then do the math, okay? I don't want this. Good? All right. Now, if the problem is 2 plus 2, is there really any work to do for that? No, there's no work. But you know what you could do, though? Say number 1 was 2 plus 2. You know what you could do? You could write 2 plus 2 equals 4 and circle it instead of just writing a 4 down. You with me? All right. So you can even just write the problem down. That's pretty much as good as showing work. Okay, enough of that. Let's do... I think that we're good, except I'm not going to do this proof formally, but I do want to show you what a proof basically is. I'm not going to do a formal proof. If you look in the book on page 157, example 3, you'll see an example of what I mean by a formal proof. Come on. Why isn't it grab? Come on. Cannot grab. There we go. Excuse me. There we go. Come on. Stop doing that. There we go. All right, you got two triangles here, don't you? And it says, here's what they tell you. This is given. I don't think I give you anything like this in the homework, but this is good for us to think about a little bit. It says BD, line segment BD, and line segment CE bisect each other. Well, it's been a while. Oops. CE, they bisect each other.
This looks like a DNA string.
Yeah, kind of. And what we're trying to do is we're trying to prove that triangle ABC is congruent to triangle ADE. So sorry. I think I'm coming down with something. I don't know. All right, this is, oops, click that button. Okay, that's A, this is E, this is D, this is B down here, and this is C right there. So I'm going to show you basically what a proof does. And why did they say that they're... What are they doing? Why did they say that that angle is equal to that angle right there? They don't tell you that. They should tell you that, right? They didn't. They made a mistake, kind of. They tell you that they bisect each other, but they should tell you that angle B and D are equal to each other. All right? Sorry. All right, so here's what we're going to do. We haven't really talked about doing proofs, but I'm just giving you a basic idea of what a proof is. So at least you can say, whew, glad we don't have to do proofs. All right, but it's good thinking. It really is, okay? Sometimes I doubt my philosophy here of not doing the proofs. But anyway, let's just do it. It says BD and CE bisect each other. So BD, this big long line right here, and EC, they bisect each other, which means what happens then if they bisect each other? They cut each other in half, correct? So this long line BD is cut in half. So that must mean those two segments are equal to each other. EC is also cut in half. But do I put one tick mark here? No, I put what? Two tick marks here. Okay? And what else? They tell me B and D are equal to each other. So angle B and angle D are equal to each other. So that's all the stuff that we can figure out. Well, we can figure out some more stuff by looking at it. First of all, we want to show that the triangles are congruent. How do I know that, how would I know that the triangles are congruent? What do I have to show? I got to show all the what? Angles are equal to each other and all the what? Sides are equal to each other. Okay, everybody good with that? Let me look at this a second. How do they say that ED... Oh, they do tell you that. See, they don't tell you all that stuff in the given. That's so weird. But in the proof, they tell you. So I was going to say, they didn't give you enough information. They tell you one more thing. Oh, my goodness. It's not my fault. At least, I don't think it is. Unless I'm missing something. So, angle D. No. What did I say? Oh, ED, side ED, sorry, not angle. So ED is equal to CB. All right, so they tell you that as well. Tell you a bunch of stuff. They don't tell you everything, but they tell you a lot of stuff, right? They told you that these two lines bisect each other, these line segments, and so we knew that this and this were equal. We knew this and this were equal. Now, what else did they give you? What else did they tell you is true? That ED and CB are equal to each other. So what am I going to put here? Put 3 little tick marks, right? So this one has 1, this has got 2, this one's got 3. Now, what else could we figure out about these triangles? We know the 3 sides are equal, so we're halfway home, aren't we? So what else? Okay, yeah, we don't call them opposite, though. Do you remember what we call them? Call them vertical angles. That's right. This angle right here and this angle right here are vertical angles. CAB and what? EAD. Do you see that? These two are vertical angles. So if that has 1 mark, I'm not going to put a 1 here. What am I going to put? 2 right there. Okay. So now we got 3 sides from one equal 3 sides of another. And then we also have two angles of one equaling 2 angles of another. But have we shown that this angle and this angle are equal to each other yet? But now we can, because we learned something just a little while ago that said if you had 2 angles of one triangle equal 2 angles of another triangle, then what must be true about the third angles? They got to equal, because we're taking the same thing away from what? 180, right? So these two add up to the same thing as these two add up to be. Agreed? Right? And you're taking them both away from 180. So what must be true about this third angle right here? It must be equal. And guess what we just did? We just proved that this triangle is congruent to this triangle. All right. So the homework that I said for Wednesday is due tonight, okay, even though it's Thursday. So you're doing 1 to 14 on this lesson. So yes, I said yesterday, since we didn't do the math yesterday, that we're just doing Wednesday stuff today. All right, so you're doing 114, section 4.2. You can find the page number. It's section 4.2, 1 to 14.